mentioned, I'm Heinz Schaffner. I should mention that most of my background is doing marathon sessions. Last year this time I did a 4-day workshop in Hong Kong. So we'll see how I do as a sprinter in a half hour to try and cover a lot of the same details. What I want to discuss is basically a challenge that we received by one of our clients who had brought actually DataTorrent in for a evaluation and proof of concept. And what they wanted to do was normalize and archive and do real-time analysis on about 1 million topic messages per second. And I mean topic messages in the sense of messaging, not a Kafka topic. And as well about 300,000 no-loss persisted messages per second. So the idea there is they had a very large data in motion type application. This is the data was already flowing and is in production, and now they wanted to add additional services and value add against that data that was moving. So this was a bank. This data was being moved across in a global fabric, where this is actually just one subset of that data. The 1 million messages a second was a peak, where this is basically an opera feed, which is taking in all the transactions from all the exchanges in real time. And the 300,000 was, again, a peak, not an average, of doing persisted of trades and a lot of other data. A little different here, though. When they persisted, there can be no loss. There can be no duplication, because even though there's a lot of them, some of them may be $10 transactions. Some could be $4 billion transactions. Don't want to duplicate a $4 billion transaction. Okay. So, to give you an idea, first of all, who is Solace and how we're moving this, Solace has been a company that's been around for quite a few years. What we provide is what we like to refer to as an open data movement. This is basically, we want it to be a single platform to do multiple message exchanges, do multiple wireline and APIs and message formats, and to provide that in a very highly scalable global environment. And it had to provide telco quality. So when you heard the discussions this morning about days, our SLAs are sometimes seconds a year. So we are telco grade. So as we joke, we were doing streaming big data volumes before the term big data was even discussed. So we do this with a range of products. This client was actually using our high-end appliances. When we say appliance, we mean truly an appliance, not some hardened Linux server, where what we did is we built multiple cards. These cards are built and designed by us, making use of ASICs, FPGAs, and cell and network processors. The idea here is most of these messaging systems today are victims of the operating system. So how do you solve that problem? Completely remove the operating system, use dedicated hardware that you would see in things like telco routers and switches, and move things at a bus level. So there's no data path at all in our environments. That means for a single appliance, I can do up to 24 million topic messages per second, and I can do 450 synchronous persisted messages. What I mean by that is I do not process the next message until I indicate back to the producer. I guarantee that message is consumed and will not be lost. That, by the way, is an old slide. We are almost double that, which we'll be announcing in the next couple of weeks. So then the other side of that is not everybody needs this volume. I should mention it is a multi-tenant environment. So obviously you're not going to have one application necessarily need all that. But we've also introduced a software version. Well, are we victims of the operating system again? No. What we've done is we've taken a lot of our code that we wrote in FPGAs and such and wrote them as kernel drivers. They are baked in at the operating system level with all the optimization, and we deploy our software versions as containers. That way you don't have to know how to set all these kernel drivers, convince your operations people that you need to do all this tuning, and we automatically get the benefit where we have it run in any hypervisor environment, almost every cloud environment. It is deployable in basically any modern environment. So we have a range from small software to large. Okay? The applications, We try to do every message exchange pattern, as I mentioned. We also are replacing, in many cases, you heard this morning, operationally, trying to save money, etc. To give you an example, we have clients that will take an HA pair of our appliances, and that will displace 200 servers running messaging services. So we have got clients that are, for TCO, just power and cooling saving pays for our equipment. So pretty exciting. So what was the requirement that we had to do to create this input operator for this client? First of all, we found that we could not use JMS. JMS, though that is one of the protocols we support, a lot of the cool features we implement are actually hidden in our connection factory like you're supposed to, so you don't have to do any code modifications and go outside the standard. However, in the input operator that's available in the Malhar, we found about a half a dozen things that needed to be modified, and so we said, fine, we'll just build it fast using our Java API, and later on we'll actually go back where we've promised to fix the Malhar version of the JMS operator. One of the big ones, because it is in production, you could go back and not change one thing in those producers. So it's fixed, it's in production. Telling an in production application you have to change, not an option. Secondly, we had to do the elastic scaling for both the topics and the persisted data. And because this was a bank running globally in production, it had to make use of our full high availability and our built-in disaster recovery capabilities, no loss, no duplication, and operate with the idempotent capabilities of the operator as well. So the first issue, how do you do no changes to the producers? What we've seen in most of our clients that are moving into a big data environment, and because a lot of our clients are telcos and most global banks, trading floors, these kind of clients, a lot of IoT these days, was you had to go back, especially for persisted data, and say, I have to modify the producer. The producers go, I have my own budget. How is this going to affect production? Are you going to give me money? What's going to happen now if I have to send it to where I'm sending it now? And maybe another messaging system. This is a great resistance to actually adopting a lot of these big data applications. So what we have is a capability which is, we call it a wiretap. That's not the marketing term. It has negative connotations, especially with all the things that are coming out in the news with the FBI and such recently. But essentially, that's what we're doing, is wiretapping that data. So for example, if you have an application today that has producers and consumers going against a standard persisted queue, rather than having to go back to that producer and say, well, I want to write this off to a DataTorrent application, so can you modify your application to write this to a second queue that I'm going to now listen to with an input operator? It's not going to happen. What we can do is I can wiretap that, so administratively in my infrastructure, I will say any message that shows up in app queue, I want it to automatically go to, in this case, the example on the slide, is a queue called DTQ. This is absolutely zero impact, because in my infrastructure, is still only one copy of that message, okay? So I can do this with zero impact. No producer is going to know. I can have separate access controls and administrative rights. Suddenly, I am doing DataTorrent processing without any change to the producer. Topic data, on the other hand, in a standard messaging is pretty dead simple. I mean, that's a whole pattern for topics. Any consumer can listen to that topic, yeah? So there it becomes a fan-out issue. If I can fan out to 24 million messages per second, I don't think it's a problem of having to fan out 1 million messages that are already flowing across the bus. The same way the topics are easy to deal with for connectivity, they're impossible to scale elastically. Why? You usually have what happens on the left. I mean, the nature of a topic is you flow that message, it hits a messaging bus or broker or whatever buzzword you want to use to describe it, but every consumer gets every message. So if I create an input operator and I made it with multiple partitions, it just means every partition is still going to get all the data. That's not exactly scaling. What Solace has introduced is something called deliver to one, which means I can have a group of consumers say, we want to cooperatively process that topic data, but I want it round-robin delivered to all the consumers that I said want to participate in this. So the other guys that all want to get all the data, that's fine, they get all their data. However, now I can start scaling this data out where if I start up more than one partition, it will dynamically start load balancing that topic data against all those partitions. If you scale it back, I will automatically scale it back. If partition dies, it'll automatically scale this. There's no need for partitioning, there's no need for clustering, there's no need for bizarre data segments and hard engineering. This is literally in the API, binary flag, yes or no to DTO. Plus, it's also routable and automatically can give me capabilities in a remote DR site, but that's another topic for another discussion. Elastically scaling queue data is actually pretty easy. Every messaging vendor today that supports a non-exclusive queue does the equivalent of what we do with topics against persisted queues. They are, again, completely scalable. It was a poor man's way of making fault-tolerant libraries and applications, as well as giving you load balancing. So that we addressed as well. However, the Achilles heel of this type of architecture is what's called a slow consumer, where all of these guys all have to guarantee sequence and order, so it has to be single-threaded, yeah? Now, I also have to share all the processing of all the file descriptors for all those connections. As a result, if you have in many of these, if I have one slow consumer of queue data, all the others are going to start getting affected. And it's not just consumers, it actually starts to put back pressure on the producers. And you briefly heard a little bit about how to deal with back pressure in that. High performance, I cannot have back pressure. I have to be able to scale, and I have to make sure that other things that are happening in the system are not going to interfere with another component. So in this case, Solace actually has patented technology to deal with this slow consumer issue. The other downside, though, of creating a non-exclusive queue when you're doing these multi-partition input operators, it actually is a lot more complex to figure out what you need to do to keep performance high, but not result in loss or, more importantly, duplication, okay? So what is the issue? If I'm doing idempotent recovery within the operator, that conflicts with the recovery mechanism of your messaging system, okay? Especially for persisted data. And the recovery mechanism in a Apex is going to be based on number of windows, how far do you back, where did you do, you've heard the whole story. But on a messaging, it is different. What happens is it is pure streaming. Acknowledgements for processing are on a per message basis, not on a window, even though under the covers, messages are using a sliding window flow control. You can start to get into issues. The first one they'll try and do is a session transaction. Session transactions appear to be a nice way because it kind of looks like a window that you're processing in the operator. However, they do cause a performance hit. They're going to introduce latency, and throughput is a function of latency because how big do I make the transaction? Do I have to put in timers? How do I know it's slow getting to a limit or a timer? It's no longer full streaming. The other side of it is they're usually restricted in how many messages you can put in a transaction, right? So it's like send, commit. So what happens then is you end up with actually pretty poor performance. Another way to solve that's called a vector send, where basically I put a bunch of messages in one big message and have the whole thing fail or roll back. Again, adds the same latency, but I'm back to the problem. I got to convince the producers to change how they're writing their application and the consumers to try and solve the input operator problem. Not going to happen. The other is the queue. So what we've done is we don't use a session transaction for this, for the operators we wrote. We basically are doing the at least once recovery because I don't need to go to the slower idempotent recovery where it has to worry about everything. Because what happens is, in all these messaging systems, when there's a disconnect or a failure on the client, which could be crash or a partition being restarted or whatever, it automatically will replay those messages back to the input operator. The problem is, though, how do you tell what's a duplicate and not a duplicate? And you don't want to be doing error checking on every message because that kills performance. So the good news is all these messaging systems provide a redelivered flag. It basically says, by the way, I've sent this to you before. You've gone away. I'm sending it again. I don't know if you've consumed it accurately. I don't know if you failed, but I'm giving you an indication to check. So suddenly you have a very efficient way to do the error checking where you only have to check when there's a redelivered flag. Any other times, I do not have to worry about any recovery mechanisms. Makes it very fast. The problem is the redelivered flag doesn't necessarily identify you as a duplicate. It basically says this might be a duplicate. Might is not a strong enough assurance to a bank that that $4 billion transaction was maybe done again in the past. Okay? So a lot of ways that traditionally you would solve that, you would put things like message IDs and application IDs into the protocol headers as you're moving these through the messaging system. Problem is, for performance, you don't put any additional protocol overhead stuff in these messages, especially to reach these high rates. And we're back to the problem again. I'm not going to be able to go back and convince the producers of this data to start putting in all these unique identifiers. Fortunately, I don't have to worry about duplicating all these things. And if I do the recovery back to the last checkpoint within in the operator, in the input operator, as soon as I start getting flag messages of redelivered flag, I will start accumulating those. I will compare those to what's being streamed in. If there is no duplicates, from then on, I do not have to worry about duplicates. So in many cases, we had to write the code to worry about it. All the testing I've done, I only ended up with one duplicate message. But one is enough to kill you, right? So again, extremely fast. The other thing I discovered the hard way is only checkpoint what you need to checkpoint, only store in these windows what you need to. So, I didn't worry about putting the transient flag on a lot of the variables and objects that I didn't actually need to persist in the operator checkpointing. Make sure you put in all the, transient out anything you don't need to checkpoint. The other is to determine what was the error. Was this a partition failed? Was it an HA failover? Or was this a DR type of scenario? Fortunately, in our environment, an HA failover is completely transparent. So they would not have noticed any of this has happened. We also, though, do provide an HA indication as a real-time event back to the operator. So if you need to know that HA had occurred, it happens. On the DR event, it's a little more of an issue, which I'll talk about in a second. The other one is people start acknowledging these messages every time. You don't need to do that. Because if you acknowledge it, if you need to do that automatic replay, you might have acknowledged out messages that were outside of the checkpoint window where you wanted the performance, so you didn't use the highest level of guarantee in the input operator to keep performance up. So they go, but if I have a window of 10,000 and now I'm going to send back-to-back 10,000 acknowledgments, that's going to kill my network and my broker. That's a very big false assumption. Every broker does lazy commits. And what they mean by that is if I say in a tight loop, acknowledging these 10,000 messages, which is literally a couple of milliseconds to generate that, I may only send 5 or 10 packets saying, okay, ACK message 1 to 50, 50 to 2,000, 2,000 to 4,000. So this is not something you should be afraid of doing. For the HA recovery, the only thing that we've really had to do, because we do this automatically as part of our APIs, which are then plugged into the input operator, they will notice a slight blip in processing. But during that slight blip, we will have, we actually suspended the operator. Why? If you have very small windows for the actual commits of the windows, why commit empty windows, right? However, one of the Achilles heels of most messaging systems, if you do an HA failover, the time to failover is a function of the amount of data that is in the broker. We do not have that limitation because we're replicating state and the actual data. So as a result, our failovers, assuming it isn't instantly detected, which 99.9 of them are in about, are actually in the multiple millisecond range. So that outage is very brief. DR, this gets difficult because there is no redelivered flag. When I'm replicating an HA state to another HA state in a DR site, I don't have the knowledge of the state of messaging in the primary. All I've done is really replicate the data. So you do not get this redelivered flag. Fortunately, again, we don't want to block, we don't want to keep checking, we don't want to poll. We have asynchronous events to indicate there has been a DR failure. Recovery is not as fast, which means when we go back to the checkpoint, we actually go back 2 more windows that were checkpointed and compare incoming data until I don't have any more duplicates, and then I know from then on I can jump out of the recovery. When I mean not as critical, DR is not something you do automatically. So for me, I can actually do DR if they detect it. And we always have, well, we don't have to. We always recommend a human do it because you don't want a ping-pong effect going back and forth. Yeah. So that's about all I wanted to cover in my sprint versus a 4-day workshop. If there are any questions, and for those people that are bored when we ask questions, here's a grade 9 math factoring problem where you start off with A equals B, and at the end you end up with A plus B. It is wrong. So hopefully somebody by the end can tell me what is wrong with that grade 9 math problem. Are there any questions? No? Crickets? We're here for the rest of the day, and if you have any questions at lunch, we can go into more details about Solace and or what we've done with the operator. And I should mention the operator is complete. It's been modified to look and feel like all the other Mahler operators. We're just going through the final performance tests for DR and HA, and that should hopefully be available for public download in a little while. We did not produce output operators. There, the JMS one works perfectly, right? So, yes, what is the... Sorry?
Right? A minus B is 0, so you cannot divide by 0 both sides.
That's right. When you go to the third step of a squared minus b squared equals ab minus b squared, you just said 0 equals 0, so everything you do after that is going to work. Grade 9 math, and we're still thinking hard on it. Your kids are going to make you think these things. So, anyway, thank you very much.